Today we are going to discuss about correlation, topic number 6. And in this topic, you should be able to show diagrammatically pairs of observations of variables. We should also be able to decide if there is a relationship between the variables. We should also be able to put a numerical measure on the strength of this relationship. We should be able to simplify calculations by using coding. Coding is not a new name. We've come across coding before. We should be able to calculate product moment correlation coefficients. And finally, we should be able to understand the limitations of products moment correlation coefficients. What is correlation? If two variables are related to any extent, then changes in the value of one are related to changes in the value of the other. Such variables are called bivariate. They are called bivariate variables. Bivariate variables. Bivariate variables, you can also call them bivariate. You can talk about bivariate data. So, bivariate data is data which comes in pairs. For example, in the xy Cartesian plane, we always have the x variable, and it is always connected to the y variable. That is bivariate data. And there may be or may not be a relationship between x and y. So I want us to just discuss something to do with the association between two variables may be seen by plotting a scatter diagram. So what is a scatter diagram? Let's start with what a scatter diagram is. And we go straight to example number 1, which is telling us, this is statistics page 115. 10 students sat a mathematics test and a physics test. Both tests were marked out of 20, and their marks are shown below. I don't want to just put the table on the board because you all have your textbooks. You can have, for example, a student A scored 4 in mathematics and 6 in physics. Student B scored 9 in mathematics and 8 in physics. All the way until student J scored 10 in mathematics and 8 in physics. So the question is, draw a scatter diagram to represent the data. This scatter diagram, you will have to represent the two marks in the same diagram. For example, if you may have the xy Cartesian plane, on the y-axis you may have physics, and on the x-axis you may have mathematics. And you can even see the score of physics and mathematics. Both of them are up to 20. So we are going to calibrate like from 0 to 5, 10, 15, 20. And then along this is 5, this is 10, this is 15, and this is 20. And then mathematics we have 5, 10, 15, and 20. We don't go beyond 20 because there is no mark that is beyond 20. Let us talk about student A. Scoring 4 in mathematics, 4 is about there, in mathematics, and 6 in physics, 4, 6, somewhere there. What about student B? This is student A. What about student B? Scoring 9 and 8. 9 in mathematics and 8 in physics, somewhere there. What about student C? 6 and 9. 6 and 9. What about D? 10 and 13. 10 maths and 13 in physics. What about E? 20, 20. 20, 20. 20 in mathematics, that is very high score. 20 mathematics and 20 in physics. That is student E. What about F? 7, 9. 7, 9, around there. What about F? G? 12, 10. 12, 10. 12, 10, yes, there. What about H? 17, 17, 17 and 17, somewhere there. What about I? 11, 13, 11, 13. What about J? 10, 8, 10 and 8, around there. So you can see, you can just see our scatter diagram. That's how it looks like. So what can we see? If, as in example 1, both variables increase together, they are said to be positively skewed. You can see if you draw a straight line that when mathematics increases, the physics also increases. So they are positively skewed. There is positive, they are positively related. They are positively related or correlated. So if one variable increases as the other decreases, they are supposed to be negatively. If, for example, maths decreases as physics increases, this is now a negative. This is negative correlation. Negative correlation. That is negative correlation. And if no straight line can be traced, meaning that all points are not forming a straight line, they are not forming a clear pattern, that means there is no correlation. We can at least say that. So in A, if you have a general kind of representation of variables, this is positive correlation, positively correlated. If you may have another one, if one increases, the other one decreases, that is negatively, this is negatively correlated. If we may have a haphazard kind of concentration, then there is no correlation. There is no correlation. If you go to example 2, let us now look at example 2, which says, in the study of a city, the population density in people per hectare and the distance from the city center in kilometers was investigated by picking a number of sample areas with the following results. We are on page 116 and looking at example 2. Let's look at it together. The table talks of area, and there is distance, and there is population density. For example, in area A, the distance from the city is 0.6 kilometers, and the population density is 50 people per hectare. In area J, the distance from the city is 0.9 kilometers, and the population density is 38 people per hectare. Now, part A of the question is asking us to plot a scatter diagram. And this scatter diagram will have to just have a diagram like we had in example 1. So on the y-axis you may have population, and along the x-axis we may have distance as provided in the table. And the distance, as we can see, the highest distance is 4 kilometers. So we will have like 1, 2, 3, 4. That is 1 kilometer, 2, 3, and 4. And the highest in population is, I can see 50. So we may have 10, 20, 30, 40, and 50. This is 10, 20, 30, 40, and 50. Let us now go to the table. Area A, 0.6 kilometers, that is around here, and 50, that is at the topmost, the maximum population axis, which is along the y-axis, 0.6, 50. What about B? 3.8 kilometers and 22 people. 3.8 kilometers around there and 22 people around there, just roughly. What about C? 2.4 and 14. 2.4 and 14, around there. What about D? 3.0 and 20. 3.0 and 20, around there. What about E? 2.033. 2.0 and 33, around there. What about F? 1.547. 1.547. What about G? 1.825. 1.825. H? 3.48. 3.48. What about I? 4.016. 4.016. What about J? 0.938. 0.9 and 38. That is how our diagram looks like, our scatter diagram looks like. Let's look at part B. Describe the type of correlation. Describe the type of correlation. The type of correlation generally, as you can see, as distance increases, the population decreases. As distance increases, the population increases. There is kind of a general straight line that is coming from the top left to the bottom right. And this is, we have negative correlation, meaning that negative correlation, as one variable increases, the other one decreases. They are both negatively correlated. Part C, interpret the correlation. Exactly, just like what I've said, as the distance increases, as the distance from a certain city increases, then the population density decreases. And that is exactly what brings about negative correlation. Okay?